Okay, let's start this video. Let's see the contents of this video. First, I will explain the various mobile sensors available nowadays, and then I will explain that why there is a need of record these mobile sensors and how we can record this mobile sensors data. And then I will explain you the two methods of data processing. One is the online and other is offline. And then I will explain the CSV file format and its available documentation for Python as well as MATLAB. And then I will show you some third-party Android applications which will collect the sensors data. And then I will explain one Python code that will use a CSV reader of a Python function to read accelerometer data. And then I will explain one MATLAB code that will use the CSV read function of MATLAB to read magnetic sensors data of mobile phone. And in last, I will explain one more MATLAB code that will use the read matrix function of MATLAB to read gyroscope sensors data of mobile phone. Before watching this video, I recommend you to watch these two videos. The first video is about the wavelet transform analysis of one-dimensional signals using Python, and second is about the audio signal processing using MATLAB. Actually, although they are not directly related with this current video, but they will be useful to provide the information about the processing of the data once they are captured and taken into the Python and MATLAB environment. The links are given in the description. Let's see the various mobile sensors available in the modern smartphones. They generally are proximity sensors and ambient light sensor and CMOS imager, that means your camera, GPS sensor for your location, geolocation, and accelerometer for the movement of your mobile phone. That will be helpful in playing some video games. Then humidity sensor to check the humidity around us, and then microphone to record the sound, temperature to record the temperature of surrounding as well as the temperature of some internal chips such as the temperature of your battery and temperature of the CPU. And then pressure sensor, that means the barometer is there. And then fingerprint sensor for security, magnetometer, that means sensing the magnetic field around us, so that can implement the compass. And then gyroscope, that will be useful in playing various mobile phone games. And then touch sensors, so we can use these sensors to record the data and process it for our applications. So question is, why to record these mobile sensors? Because the Android operating system itself records the output of these sensors to assist us while we are using many applications such as camera or playing some video games, etc. And we can also record the sensors for our own applications, such as we can implement various projects or applications, such as to control the robots and machines, and to identify the metallic or non-metallic objects. We can implement the study of some machine part which is vibrating too much, and we can differentiate the normal and faulty operation of machines based on its sound, and to study the movement of some machine and body's part, and to control some activities based on the mobile phone orientation, etc., etc. There are many other things that you can do with these captured sensors data. Now let's see the two schemes by which we can capture and process the data. So we can record the sensors data and process it offline in one scheme, and in other scheme we can process the data online. That means we can capture, at the same time we can process it on our local PC which has Python or MATLAB or some any other data processing software. So the method one is easy to implement, that means offline method is easy, and the online one is complex to implement because we need to establish a real-time communication link between our mobile phone and PC. So we can transfer the data to the PC in real time, and at the same time you can process it. So it is a little bit complex, and in this video I'm going to explain only this first part. In this slide you can see the online processing steps. Actually, in mobile phone we have various sensors, as I said. There is one Android app which is running locally on this mobile phone and which is capturing the sensors data in real time. And now we establish a communication link between the mobile phone and our PC, and over this link this captured real-time data is transferred to the PC, and we process this data simultaneously. So that is our overall online processing, and this is the offline processing where the local running Android app is capturing the sensors data. And what does it do? It stores all the captures data as CSV file locally in the memory of the mobile phone. So we access this CSV file and transfer this CSV file to our PC, and then process this captured data on this PC using either Python, MATLAB or any other processing software. So this is actually the offline mode, and in this video I will explain only this. Now let's see what is the CSV file format. CSV actually means the comma separated values. So this file you can open in the notepad, and you can also open in MS Excel. So when you open this file you can see the various captured data in various columns. So this particularly file has the 4 columns, 1, 2, 3 and 4. So the first column is designated by this text of the first line. So the first column is representing the time, second column is representing WX, that means the data which is along the x-axis, and then data along the y-axis is the third column, and the fourth column representing the data or census data along the z-axis. So this is the data actually which I obtained from gyroscope of the mobile sensors, and this is how this file looked like in MS Excel, quite organized. And one thing common is there, you can see that the first line is a text line. So we should be careful when we import this file and we read this file in either Python or MATLAB. So we should take care of this first line. So we have to separate this text line from this non-text, that means the data, during the processing. Now let's see the documentation of the CSV reading. You can read the CSV file in Python using the csv.reader function. So what is csv.reader? You can explore more by clicking this link. This link is given in the description. You can read about this CSV reader and its various options. So we have a CSV writer also in the Python. Similarly, if you go to the MATLAB documentation, you can access the information about the CSV read function of MATLAB on this link. So click this link, you will get the information about CSV read and its various applications mode. And there is a improvement over a CSV read function. Actually, the CSV read function is a very old function implemented in the MATLAB. You will find this in the old versions of the MATLAB, although it is working in the current versions also, but probably it will be eliminated in the future version. So now its improvement is the new function, which is the matrix read instead of CSV read. So this is the new function which is introduced in year 2019, and it's obviously the improved version, and you can do a lot of things with this matrix read. So what you can do, You can refer its documentation on this link. You can read many types of files using this matrix read function. Now let's see what are the third-party Android applications which will run on your mobile phone to capture the sensors data. So if you open the Google Play on your mobile phone, you just type the sensor data collector in the search, and then you will find the various applications, okay, in the Google Play. You can install them, any one of these. Almost they are all good, but personally I liked this app, which is the physics toolbox of Vera software. I found this software very useful with a very easy and clean interface. And there is another one which is the data collector of another company. Actually, there are two categories of the app. One which stores the mobile sensors data into the CSV file for offline processing, and there is another category which they don't write data into the CSV. They directly send to some web server for online processing. So this app belongs to the second category. That means it does not store the data in CSV locally in the mobile phone. It sends the data to some web servers for online processing. And this type of application actually stores all the data into the CSV file format locally in the memory of your mobile phone. That file you can later access. So this is your mobile app, which is actually the physics toolbox sensor suite. It has both free as well as paid version. The paid version is of around 250 rupees or something. So let me jump to my mobile phone and let me show you that how you can record the data using this software. Okay, this is my screen of mobile phone, and let me show you that how you can record the Android sensors data using that third-party application. So here you can locate that this green one, which is a physics toolbox. You can open it, and when you open it you get this type of interface. Here you can see that the G-force sensors data is being displayed with these waveforms, and when I shake my mobile phone you can see the variations in these waveforms. So you can record this data, and from the left menu you can select various sensors which are available on your mobile phone. For example, you can see the linear accelerometer, gyroscope, barometer, and then proximity, magnetometer, etc., GPS, and many other applications are also there. And for example, if I want to record this G-force sensor, then I can do it. You just see this red circle with a plus button. Just pressing this button you can record your data. So let me do it. Okay, you can see this pop-up at the bottom. It says that data is being recorded. So for the required time you can stop it. So let me stop it. So now it asks me to choose the file name, so that it is the G-force. Okay, so G-force 1. So done. Okay, so this file is saved, and it asks me to save this file either at the local storage, or you can share it via WhatsApp. You can save it to the Google Drive. You can mail yours to yourself. And let me select the local storage. So I'm opening this file explorer. So I'm choosing, let's say, the internal storage folder, and just simply pressing this OK button, this file is saved. Okay, so let me show you the stored file. Let me open the explorer. So this is my internal storage, and see at the bottom you can see this one, gforce1.csv is there. So of the size 212 KB. So let me open this file, and this is the data you can see which is available in the CSV file. So the first line obviously is the text you can see, which is designating all the columns. So first column is the time, second is the GFX, third column is the GFY, that means data along y-axis, then data along z-axis, and then total data. So here you can see that all captured sensor values separated by the commas. That's why it is known as the CSV file. So it's a simple file of very small size. You can store this file to your laptop for further processing using MATLAB and Python. So in the coming slide, I will show you that how you can read this file using Python and MATLAB and how you can do the processing. Okay. So let's jump to my presentation. Now we can process this recorded CSV data using Python and MATLAB. So this is my Python program, which will use the CSV reader function to read the CSV file, and we can process it. So I will read the accelerometer data first, which I have stored as acc1.csv file on my mobile phone. So here first you need to import some libraries, such as you need to import the NumPy and then matplotlib, and then to read the CSV you need to import CSV. Okay, CSV is there already there in the Anaconda, so no need to install it separately. And this is the command which reads the CSV file. So first we execute the file open command. Then we are defining the name of our file, that is the acc1.csv, which is residing in the current directory where this program is also residing, and this with the reading attributes. And then we are executing the csv.reader function, and then output is collected into the data variable in the form of list. Okay, so now this data, since is in the form of list, it is not usable, you cannot plot it. So first we need to convert this data into the numbers so you can plot it. So you need to convert this as a NumPy array. So we are converting this list data into the array, so np.array, and passing this data, and data type is the float. So whatever we will get into the data 1, the all values will be of the nature float. And then what this one column is doing, actually it is reading the data from the second row. As I have shown you that the first line of the CSV file is the first line of the CSV file is storing the data designation parameters such as time, and then if you remember that wx, wy, wz. So that is the first line which is of the text. It is not the data of some integer or float. And from second line the data starts. So that's why we are ignoring the first line, and then everything except the first line is stored into the variable data 1. So since data 1 has actually as I am reading the accelerometer data, the accelerometer data has actually the 5 columns. Okay, so we are extracting them one by one. So the time is at the first column, so we are extracting as data 1 all rows, comma 0 means the first column, and then ax, that means the second column we are extracting, that means the data along the x-axis, and then data along the y-axis, that means the third column, and then data along the z-axis, that means the fourth column, and then data along the this 80 is the total signal which is at the fifth column. So we are extracting this as 80. So now all the signals are separated column wise, and then we can plot them. So these are the plotting commands. So we have initiated one figure of size 20 by 10, and we are plotting all these extracted data in the same plot. So here you can see that we are plotting the time versus AX, time versus AY, time versus AZ, and time versus AT. So total we have 1, 2, 3, and 4 plots in one single window. So this is the title, that means accelerometer data, and you can put the X label, Y labels as time and accelerometer values. So these lines will give one figure which will include all the data on the same axis. And now we are plotting them separately using the subplots. So we are initializing one figure, and then this subplot is plotting only the AX data with the red color. Okay, and then these lines plotting the AY data with a green color. And these lines are plotting the AZ data with a blue color, and these lines are plotting the total data AT with a black color. Okay, so here you will get in a 2 by 2, that means you get 4 figures like this as subplot. That means the first one will include your AX, second one will include AY, this will include AZ, and this will include AT. So you can see all the 4 waveforms side by side. And here I have written some more lines to process the data. Since we have separated the data, so we can process it as per our requirement. You can filter it, or you can do the wavelet transform of this data like this. So to take the wavelet transform, you need to import first the pywt library, and then executing the pywt.dwt function, and then I am finding the discrete wavelet transform of this AT, okay, with the wavelet db5 and using the signal extension mode symmetric. And by the wavelet decomposition, I am getting the 2 coefficients, that means approximation coefficient and the detail coefficients, and I'm plotting this. So since I'm not including this in the main program, you can separately execute it on the command prompt. So let me show you that what is the output of this program in Python. So let me open the Spider IDE. So this program I have already written. So let me run by pressing this run button. Okay, so these are plot which I am getting. So this first plot is generated by executing the plot command where I have plotted all the this one, where I have plotted all the collected signals in same window. So AX versus time, and AY versus time, AZ versus time, and AT versus time. So all are in the same window. And this is the second plot, which is using the subplot. So this is my AX, this is AY, accelerometer along x-axis, accelerometer data along y-axis, and accelerometer data along z-axis, and this is total accelerometer output. So here you can see that how you can read the CSV file and access the signals separately, and how you can plot them. You can also do the processing such as wavelet transform, as I said. So for this I need to import the library, import pywt, and then okay, let me copy this command from here instead of typing. So I can simply paste it here. So I am finding the wavelet transform of it. So I will get the CA, that means approximation coefficient, and detail coefficients here. So I'm getting CA and CD, and then I can plot the CA and CD. So this is what I'm getting. This is the approximation coefficient, and let me get the detail coefficients. And this is this plot shows the detail coefficients of that signal AT. So this is how you can process your data for your further requirement. So let me jump to my presentation. Now let's see the MATLAB code using the CSV Read. So here we will use the CSV Read function, which is an old function of MATLAB, to read the magnetic sensors data of my mobile phone. So I have stored the magnetic sensors data of my mobile phone as mag1.csv file, and I have imported this to my laptop. So here I am reading this file mag1.csv, and all data will be stored in this data variable. Now what the 1 and 0 is doing here, as I said, the first line of the CSV file is carrying the text, so you have to ignore it. So I am reading from the second row. That means this 1 and 0 is actually the reading file from second row, okay, and taking all column values. So I have left the first row. So that means all numerical values are stored into the variable data. Now I am extracting the data, column data, in different variables. So as I said, that first column is representing the time. So from the data, I am extracting the time. That means all row and the first column. And then data along the x-axis means all row and the second column. And then data along y-axis, all rows, third column. And data along the z-axis, all rows, fourth column. And then total data that is being extracted by the all rows and then fifth column. So you can extract all the columns one by one like this. So now we have the data, all the data in these variables, data x, data y, data z, and data t. So we can plot them. So we need to plot these data. So we can plot, I am using the subplot. So the data x is plotted in red color, and then data y is plotted in green color, data z in blue, and then total data is plotted in black color. Again, these lines I have written for other processing, as I have shown in the case of Python. Here you can take the wavelet transform of these data. For example, this command is taking the wavelet transform of the data t with the wavelet db5, and then signal extension mode is periodic. So by the one label DWT, you will get the approximation coefficients and detail coefficients, and you can plot them separately. I will show it in the MATLAB. So let me jump to the MATLAB. Okay, so this program is already written. Let me run this program. So, okay, this program is run, and I'm getting two figures. In one figure, I am getting all the collected data on same axis, and in second figure, I am as I use subplot, so I am getting data separately in 4 windows. One is along x-axis, other is y-axis, z-axis, and then total data with a black color, if you remember. So this is the program where I am getting this these plots. So I can take the wavelet transform also. So either you can execute that command, or you can call the wavelet analyzer. So when you execute the wavelet analyzer, this window will open for you, and from here one dimensional, that means the wavelet 1D, you can choose. So when you choose it, you get another pop-up where you can import your signal, import from workspace. So import the signal. So here you can see those separated column wise data all are visible here. So time is visible, data z, data y, data x, and data t. So for example, let me call this data x. So this data x is displayed here, and now you can choose your wavelet. For example, let's say db5, and then decomposition labels are 4, and then you can analyze it by pressing analyze. So here you can see that after 4 level of decomposition, your signal becomes smooth, and these are your detail coefficients at level 1, 2, 3 and 4, and this is the approximation coefficient at level 4. So this is how you can do the wavelet analysis. You can denoise it, compress it, and you can do a lot of things. Okay, so now let me jump to my presentation and see another example. This is actually the MATLAB code using the new function read matrix as I introduced. With this function, I will read the mobile's gyro sensors data. So I have already stored the gyroscope data in the file gyro1.csv, and then by executing this read matrix function, then it will automatically read all those values and store in the variable data. Now one good thing is that as in case of CSV Read, we have manually separated the first line, but here this is the inbuilt feature of the read matrix that you just give the name, the first line, which is the text line, will automatically eliminated, and all numerical values will automatically stored in data. So that is a good thing about the read matrix. And now we have separated all those columns in time and in data x, data y and data z, and then we have plotted. So here I am plotting in the subplot. It's a 2 by 2 plot, so we will get 4 matrices. So we will get the 4 windows of graph. So the first I am plotting the data x with the red color, and then I am plotting the data y with a green color, then data z with a blue, and also in the fourth window I am plotting all the data combined together on the same axis. Okay, and here again are for doing the wavelet analysis. You can do the wavelet analysis of any of these data, and let me jump to MATLAB to show you that what type of output you will achieve. So let me open the MATLAB. Okay, so this is my file. You can see I have already written it, and let me press the run button to get the output. Okay, so this is the output which I get by running this program. So here you can see that the first window displays the data along x-axis in red, and then data along y-axis in green, and then data along z-axis in blue, and then these all three are combined together on the same axis. So this is how we have used the read matrix function in this case. So let me jump to the presentation. So that's it for this video. Thank you.